C is considered as a middle level language. Of course, it is not considered as high level language, or it is not considered as a low level language. But the point is that it has the power of high level language, or it has the control of a high level language, and it has the flexibility of low level languages. That is why it is considered as a middle level language. What do we mean by the control? That the coding style is relatively easier than a machine language. In C, the coding style is relatively easier, and in C language, C can interact with the hardware, so it has the flexibility. With the flexibility, we mean that we can write a code that can very efficiently execute, or we can write a code that can have a very small size, or we can write a code that we require to execute in a specified time. These are certain requirements in embedded systems that you will discuss in your further courses, that you have to write a code that executes in this much small time. For example, if you have to transfer data to a USB device where you have to send this number of bytes in this much seconds, as you know, there are standards that whether a USB has 4 megabits per second, this kind of speed. Now this kind of speed has to be certain, has to be confirmed that your device is able to transfer data at this rate, and this objective is accomplished in the programming, that your program is able to take data from the operating system and transfer this data over the USB interfaces to the USB device. So this kind of objectives are required, are desired, and these objectives are possible in C language. That is why it is called flexible, and this is and the reason of this flexibility, that it can manipulate bits, bytes, and addresses. In manipulation of bits, we mean that we can access a single bit in a byte, or of course we can process these bits, or we can modify these bits, we can modify the bytes, and we can write to certain addresses in memory. You will see that in an embedded system we have addresses of registers, we have addresses of memory. So every physical unit of memory or a processing unit have certain address, and these addresses can be accessed in C language, and it is so these addresses can be accessed, or these bits or bytes can be accessed in a machine language, and the same can be done in a C language. So that is why C language is more flexible than a high level languages, and it is easier to write code, and it provides a better control over the code than machine language. So that is why it is called a middle level language. Similarly, portability or portable. What do we mean by portability? That we write a code for a particular hardware, for a particular operating system, and if we have to develop, or if we have to execute that code on some other platform, operating system or embedded system, then for a C language program we can compile these codes for that, for some other hardware or some other operating system easily. That is why this is called portable. So we have not to rewrite the whole code to get functionality on some other platform or some other operating system. In embedded systems, you will see that we have different microprocessors or microcontrollers from different manufacturers, and all are having different machine or op codes, so their programming becomes different. You have to specify your code for one particular hardware or one particular microprocessor or one particular microcontroller, and you have to write separate code for some other hardware, some other microcontroller or microprocessor. In a C language, it is very easy to target the end devices. You will see in your future courses, in microprocessor interfacing courses or embedded system course, that how you can compile the same code for different target devices. You will see these things. So C is a kind of thing that is portable, and this is one reason that C is used for embedded system programming. And as I discussed earlier, that as a computer engineer, the devices, to write code for devices or to develop device drivers, it is the core objective of computer engineering. So C language must be considered and must be understood by every computer engineer. Similarly, data type conversions is sometimes a requirement. You will see in next slides that in C language we have 5 types of data types, like we have character, integer, floating point, float, and double. So we have different type of data types, and C allows to convert from one data type to other data type. We can convert a character into an integer for certain reasons. So this conversion is possible in C language. It gives a lot of flexibility. The last point, of course, may be a negative, maybe a plus, that no runtime error checking is done in C language. That once you have developed a code, then C doesn't consider the errors like there are memory leakages, memory losses, or any other kind of such errors. C doesn't consider that, and it considers the responsibility of the programmer to manage such things, to manage the hardware resources. So C is not considering runtime errors. Runtime errors are considered those errors that occur when a process or when a code is executing. So C language doesn't consider these errors. Of course, this will disturb the functionality of your written code, but again, it is considered the responsibility of the programmer, not the responsibility of the compiler or the language.